Recording. So the last part of the technology in Hadoop, not Spark, the last part is we always talked about online analytical processing, analysis of the data, right? Hive, all these technologies are allowing you, Hadoop, everything, right, is OLAP. What is the OLTP component of Hadoop? Where you can now look at transactions and then you can retrieve the data just like Oracle, etc. So that's what Hbase is all about. Okay, so today we will cover Hbase as the first part. So the difference is this, always remember, the only one OLTP component in Hadoop technology is Hbase, right? It is widely used, but there are better technologies. Why? Because people always prefer Oracle or any relational database in the place of Hbase, but as part of Hadoop, this is existing. Okay. Now, how Hbase works? It is very similar to Hive. What they have done is, this is your HDFS. What they did is they projected a part of HDFS file system into something called region servers and master servers, and allowed all the transactions to go through these masters and regions, which will finally be updated into HDFS. Okay, so whenever we talk about Hbase, you will always hear about these two, master servers and region servers. Okay, so it's like Hive, but only thing is that they created this separate architecture. Why that separate architecture is because Hive is already, you know that HDFS and Hive are OLAP based architecture, right? So to make sure that every time the concurrency and the transactions are being supported, they created Hbase, and all the transaction logs, redo undo logs, everything is managed by this master region servers. Okay, so what I want you to do is just go to forourson.com/passion and please open the document. It starts with the real Hbase OLTP component. You can see this file if you look at the screen, this file, and just click on that. Okay, so OLTP on Hadoop, you will get a document. So this is the workbook for our Hbase, right? Now I am assuming that you don't have Hadoop, or you are not working on Cloudera virtual machine. So the first part is containing the details about how you can install Hbase from scratch. We don't need it. We need to use the Cloudera virtual machine in which Hbase is already inbuilt, but the document covers the details if you want to install it from scratch. You don't need to do it, but in case if it is needed. Now let's see what is this architecture. I want you to look at, open another tab, and can you please type Apache Arrow. Okay, this is one of the latest technologies. Just to click on Apache Arrow, and look at the home page. No, Apache Arrow homepage. Okay, I think this is the right side, is the one. Oh, no.
I think the same arrow.apache.org.
Yeah, arrow.apache.org.
No, you
is
click
this.
on the left, right itself. Yeah, same thing. On the right hand side, the wiki, you can, yeah.
No, this is not. This is GitHub.
No, Right, click on the right side.
Yeah, here, yes,
yeah.
yes, this is the one. Okay, so just click on that and just go down, and can you please understand what is the meaning of this diagram? And that's clearly telling you what Hbase is also all about. Look at this diagram which you are seeing on the screen. Okay, you can just make it a little bit bigger if you want to see. Okay, you understand what is it? What it is? This is the first time that you are coming about a word. It is a columnar database. Hbase is a columnar database. What is Oracle then? What is all the other technologies then? All the relational database? Row based. So the first part of this figure is telling you how a row based architecture works. Okay. So whenever you are having row based architecture, all the columns are going to be represented like this, and every row will be having a complete data, correct? And we call it as tuples in the relational database world, right? And you just do a transpose. If you are remembering your mathematics, right? Matrices. How will you do a transpose? The rows will become columns and the columns will become rows, right? The moment you are doing this, and then you readjust all the similar rows into one particular place like this, and like this, and like this, and arrange that data in that format, what will happen is, whenever you are querying, that query becomes multitude faster than the normal approach. So columnar databases are now controlling the fast way of retrieving the data. Remember, the best format in Hive was ORC, optimized row columnar. That is the full form of ORC. They approached in the similar way, and they have given that scientifically that the CPU will be very efficiently be able to retrieve that particular data when you are representing as a columnar database. Now, Hbase is a columnar database. Now, I'll tell you how they have internally implemented it. How many of you are familiar with a hash table in Java? What is a hash table? Key and value, right? Imagine that I have a hash table in which there is a key and the value is another hash table which has got a key and value. This is the value, and this value is another hash table in which there is a key, there is a value. Imagine in your mind a structure like this, and now you want to retrieve a particular data for a particular key. Entirely this one will be given to you. If you want to retrieve a particular cell, inside this, you get this particular value. Then you get it very, very faster. This is how Hbase is implemented internally. It is a hash base of hash table of hash table of hash table of hash table internally. And you get the data very, very fast. Okay, and they have brought a new concept also. Let's assume that, okay, a customer has got name, address, let us say a zip code, okay, and there are so many other fields. Okay, for the customer there is any insurance number, claim number, all these kind of details are there. What they have introduced is that the similar items for a particular customer, don't call it as columns, call it as a column family. So you will create a column family in Hbase. In the column family, you will tell that, okay, I have got a name, I have got a address, I have got a zip code. Okay, so this is a one column family. This is another column family. This is another column family, and each column families will become the values inside the hash table. That is how internally it is represented. You don't have to worry about the internal architecture, but I'm just telling you what is the difference and how it is retrieving the things very, very fast. So, if you look at the document which I have just given you, look at this. So, there is particular data, customer ID, name, city, product, amount, etc. And what you do in Hbase is you will create a column family, and you can see that The customer is a column family with a name and city. So name and city I combine together into one column family called customer. And I have combined the product and amount into another column family called sales. Understand? And now you imagine that against this particular key, there is a hash table, and inside that there is another hash table, and you are able to retrieve that particular data. That's the basis of how Hbase works. Okay? So what we will do, we will create an Hbase table. We will start Hbase. So please do it along with me. Just scroll up, come down, and you can read this particular theory. Whatever I have told you is explained with a little bit of theory. Go to this particular page, which you see that how will you be starting Hbase in your this one. Use Hbase for the first time. Take this particular page. Just scroll down. It's a pretty good document. You can just refer it.
Document name I forgot.
Real oil TP. That
Real Hbase.
Yeah, real Hbase, the oil TP on Hadoop. Okay, so just come down using Hbase for the first time. Have you identified this particular page, right? And then look at that. There is a master and a region, as I told you. Okay. Now sometimes the Cloudera virtual machine. What happened? I don't have the page number inside this document, unfortunately. Look at this page. Look at this. Oh, right. Just scroll down and you can find out, right? Sometimes the Cloudera virtual machine will give you an error. That is why I have given you that 5 steps there. Why? Stop it and delete that Hbase directory which is existing and freshly start the master server and region server. Remember, in Hbase you have got a master and a region server, right? So what we are going to do, we will start with that particular command. Okay, sudo service hbase master stop. So I am starting the virtual machine, and in the virtual machine open a command prompt.
So that means whatever is the Cloudera we installed, that one we are removing now, stopping and reinstalling.
Yes, correct. Why? Because there is sometimes that particular directory gets corrupted. Okay, so we don't want that corruption to be there. That is why freshly we start it. So sudo, you know what is sudo? The super user command. Okay, sudo, what is that? Service, right?
Yeah, service.
Huh.
Yes.
Hbase
Hyphen
master
stop.
stop. So first you are stopping the master. In Hbase you have got master and region server. Okay, stopped. And what is the next one?
Sudo service hbase
Right.
hyphen region server stop.
Region server is a single word, right?
Yes.
Region server stop. So you can see that it will take some heartbeats and then it will be stopping it, as you can see on the screen. So look at that messages. You will get the master and the region servers. So understand that Hbase internally contains master and region servers, which will be exposing the data which is there in the Hadoop file system as a OLTP based system. Okay. Now what we are going to do, remove that Hbase directory, right? How is that? Hadoop fs minus rmr
Slash hbase.
But Ravi, I got a no masters to stop because no PID file.
That's because it's not running at all. Leave it. Just delete this.
Delete that.
You should not get that message. So we have cleaned the Hbase. That's what it is doing. Right? And now you have to do the reverse, right? Sudo
Service
service. First you will start what?
hbase master
Hbase master.
start.
Alright. And then Hbase region server start. So once the master and the region server are started, you are ready to use your Hbase commands.
So every time we have to start and stop going forward?
No, for first time. That's why the heading is using Hbase for the first time. Right? Alright, let us create a table, and now you are going to see no SQL is supported on Hbase. It is not SQL based OLTP. Again, see the problems, right? That is why it has not gained very wide acceptance. So, how will you create a table? Type create the name of the table and a column family name, all in single quotes, no semicolon at the end. But you have to start the Hbase shell. How will you start the Hbase shell? Start Hbase shell. That is a command. Hbase shell. Press enter. You should not get any error. And you should be seeing the Hbase shell now.
You gave like a /bin.
No need, because if you are installing it, that's why.
Directly you can use
Right? So if you are getting an error, that means there is something got corrupted. And if you have done the steps that I have mentioned to you earlier, stopping the master and region server, you should not be getting any error. Okay, what is the command? Create test with a column family. The command correct? Oh. And the type list. Oh. I think there is some problem.
Server is not running.
Says undefined local variable.
So server is not running.
Where is the error? What is the error? Table must have at least one column family. Yeah, there is a column family. Create test. Oh, there is a comma. That's a problem. Okay, you should not get any problem. Test comma CF. Yeah. Sorry, just to put it as a comma. Create test comma CF. So what's the name of the table? Test. And what is the column family? CF. Did you add any columns? No. You just created an empty table test with a column family. And now type list. You should be seeing a table test is retrieved, correct? So table test is there. Now please look at the document how to add the column family. Some very interesting thing. Please listen. Put is the command. Name of the table is test. Look at my document. Name of the table is test. You are creating row 1 and the column family name is already we created CF. In that you are telling that I am adding one column called A and the value is value 1. See the syntax, little bit clumsy syntax, right? So put test row 1 CF colon A value 1.
So what is the row 1 Ravi here? Row 1 is like a row?
The row, the value,
Okay.
right? The row ID and the value.
Okay. That is a value CF one or
Value 1 is the value, yes. Value 1 is a single word, yeah. So type the command. Can anybody tell me the command? Put?
put test
Yeah.
in the single quotes,
Yeah.
comma, row 1,
Yep.
comma, CF, comma, value 1.
CF, comma, A.
CFA, no comma.
Huh?
Oh, it is Colon.
Yeah, colon is
Yeah,
Colon.
colon is value.
value.
Value 1.
So it's not.
Yeah. Zero will be
Okay, what I want you to do is, can you please repeat that with value 2? Please repeat it. Last one will become value 2.
and column A is
Again, column A only. Please look at my screen. I am just changing the last parameter to value 2. Are you seeing? And again, do one more thing and the last value to value 3. So value 1, value 2, value 3. Only the last parameter. All the remaining is exactly the same. Okay, now you will be very interested to see the table. Do a list. And then scan. Okay, remember, if you want to select star from, that is scan. And then give the table name test. This is the beauty, this is the power of Hbase. So please listen what is happening. I want you to imagine something. The rows you change into columns. Already you know how that columns are getting changed, right? Now you imagine that you are in the space, that columns are like this, okay, in the space. First value you put in, Hbase will automatically tell that at what time you put that particular value. Next value you put in, it will again add the timestamp of the next value. Again you put in, it will add the timestamp. So timestamp by default is an attribute of every column that you are going to add. What is the advantage? Whenever you do the select star, it will tell you the latest value, because the designers of the Hadoop and Hbase understood that almost all the analysis that you are doing on analytics are time series, time based, right? Last month what happened? Last 6 months what happened? Compare last 6 months with the previous last 6 months, right? So what they added is added a timestamp field by default, so that it will always fetch you what is the latest.
Instead of going for the whole table.
That's what you are seeing as the timestamp. So only the top layer is getting created. Actually, value 1 and value 2 are also there. I forgot the command. We have to search how to get that particular value. Let's see. I'm just searching for the command. Get all values of a column family in Hbase. Scan, test, and comma, columns, arrow, okay, comma, columns, arrow, And what is our column name? CF colon A. Yeah. This is another way of getting a particular column family. If you have column family A, B, and C, you will just give columns equal to. You see, the comes is syntax, right? So it's a little bit of shell-based syntax. I want to find out all the values. Where is our other values? Value 2 and value 1. Just search for Hbase shell. You will get all the commands. Hbase shell. Hbase shell commands. Yeah. Get underscore table. Try this command, get underscore table. I just saw it. I don't know whether get underscore table. Where is the command prompt?
Get test to row 1, you can give
It's giving only one value. Get underscore table test.
row 1. I think
No, it's not giving any data. Get table 10. No. Time to live list. Right.
Can't get address from the software.
Sir, Ravi sir.
Huh.
So I got one command.
Huh.
Scan,
Scan.
test,
Right.
output, comma, and in the bracket raw,
Huh.
capital,
Yeah. Arrow mark. Huh.
greater than true,
Huh.
true.
Single quote.
No, just true, just the value true.
Huh.
Comma,
Huh.
capital versions
Right. Versions.
greater than 1000 or maybe
Greater than, okay, greater than 1000. Okay, all the versions, right?
Yes.
All right.
It is raw,
Huh?
Not row.
raw, not raw.
RAW.
Raw equal to. Is a single quote. What's the command?
Scan space test in the quotes, comma, and in the curly brackets raw equals greater than true. There is no space.
Did you try the command?
Yeah. I got all the values.
Scan test. Please look at this command. Okay. Control L. Okay. Tell me.
Raw. There is no space at all in the curly brackets.
That won't create any problem.
Okay, then the command is right. Scan, test,
Versions.
raw.
Versions or version?
versions.
Okay, and greater than or
Equals to greater than, yes.
Huh?
Equals greater than, yeah. Equal greater than, yes. Now it is right.
is it single quote?
No
1000?
quotes. This is the right now.
Ah, yes, correct. So please look at that. Now you can get all the values. So you are now asking for all the versions, correct? So value 1 and value 2 is coming. Look at that, different timestamp, right? So it is giving you all the values which are based upon whatever timestamp that you have inserted.
So I mean, we both are can't get master address from Zookeeper error.
You have, it didn't start at all. Your virtual machine itself is not having a problem.
Okay.
Yeah, that's why.
So what might be raw standing for?
Pardon?
What is raw might be standing for? Even I thought it should be raw first, but
No, I think raw is give the data as it is without any compression or anything like that. Raw data,
okay.
right?
Is there where condition? There is no concept of where condition.
You can, but you have to write the scripts and all, right? That's the difficulty, right?
I'm getting only one row.
It's not become popular.
So what's it?
I got only
You
one
included
row.
all the-
Yeah. I got only one row. What about the nine rows?
Versions. You're wrong. Command is wrong. Versions. Very less used, but as part of Hadoop technology, if somebody is asking what is Hbase, right? You might be interested in that. Okay, one last command. Normally you won't do this put, get and all. You will use scoop command and look at the last page of your document and just execute that, the document that I have given you. Look at the last part. Can you please execute that? What is it?
To create table and
Yeah, department.
No, already there, right? The KDB.
What is that?
Bringing from hive.
Absolutely. So instead of this one, hive table, if you are writing Hbase table and if you give the corresponding column family name, you will be automatically loading the data from Hive or MySQL to Hbase. And that is how the people will be loading the data into Hbase. So if you want, you can try that particular command now or later. But remember that scoop import supports the loading of the data into Hbase as well. Right? So just to go through that document as one of the very important things that is needed. It is mainly for the interviews. What is Hbase? The OLTP component, right? Master server, region server. Just to remember that. Okay. For the sake of completion that I just told you. Just you have to make sure that this is there. If this is gone, everything is gone. Okay. Last time it happened. So it had that box, right?
square box.
Yeah. Okay. Lot of different storage mechanisms were available, and the best possible way to start this thing is please search for modern data lakes with Minio part 1 and part 2. You will see 2 articles automatically suggested by Google, right? And you will see a video also. For example, if you look at the videos, modern data lakes with Minio, there is a first hit. That video and that 2 articles, all the 3 are mine. Okay. So the video is what I have presented to Jack's Big Data, and the 2 articles I have written for Minio. It's actually not Minio, Minio. Okay. So if you go to all, so please make sure you are watching this video as well as There are two articles, Modern Data Lake with Minio Part 1 and Part 2. Okay, it should be the top hit, right? Just to subscribe on Medium to me so that whatever article I'm writing, you will get a notification as well. So click on that, Modern Data Lake with Minio Part 1. Right? So these two documents you use as the workbook for this session, right? I am not creating a separate one. You can just look at that, and if you just drag down, and this is the fundamental that you should understand. We are moving away completely from what we have learned so far to a new type of storage. We were all these days talking about blocks, and you already know Hadoop. The block size is 128 MB. 3 copies are created by default, right? And the name node will be managing the blocks, and the data nodes will have the copies of the blocks. Name node will have a journal, and it will store which block is stored on which data node. All that fundamentals we have seen, right? And we told that if Hadoop is dividing the data, say twinkle twinkle little star, that 4 lines of the poem into 4 data nodes, like what we have all told earlier. We also told the MapReduce paradigm. Whenever you execute, the yarn resource manager will take that MapReduce, will go to the data and will execute it, correct? To the individual data node. And what was the motivation behind it? You don't want that entire data to be traversed into network. So you wanted to avoid the network by going or by moving the computation on to the data nodes, and you executed it, correct? That is the fundamental of Hadoop. The people were unhappy. They told that no, we don't want that architecture at all. Why? What is this MapReduce? It is an ETL, it is a batch process. Always remember that. Hadoop is not for real time, correct? We just saw the difficulties of OLTP, that comes in syntax, how to use it and all those things, right? But mostly all the technologies that you've studied, from Hadoop to Hive and all the MapReduce, whatever we have done, everything is for batch analytics, correct? And analytics happens on large amount of data, right? And analytics is not real time. If I want to predict a message to Suresh, let's say Suresh is in a gas station, swiping the card, he is buying gas. Immediately the credit card company is understanding that Suresh is at Baymeadows gas station. They look at the past history of Suresh. Okay, he likes pizzas, and immediately the credit card company is sending a notification to Suresh. Hey Suresh, you are in Baymeadows, you are at the gas station. We just saw that you swiped your card, but 100-meter distance there is a pizza shop. We see that you like pizza. If you use Citibank credit card, we will give you an offer. That message which goes to Suresh is online. Please understand very, very clearly the concept, okay? That's instantaneous. Because after Suresh has driven back from that gas station, no use in sending a message, correct? So that should be online. But when I make that message to Suresh, I am referring to something. What is that I am referring to? That 6 months or past history of Suresh, correct? That past history of Suresh is 10 years of data. Correct? What did I create in order to search? Can you tell me what is that official word? What will I search in order to find out what is the like of Suresh? How will I get the answer, Pisa? It's called machine learning model. You created a model out of the data. That model is like an exe file. Imagine 20 years of whole data you are giving to a machine learning algorithm. A machine learning algorithm studies it, understands it, and finally creates a small piece, an exe file kind of thing. That's the model. That is very rich. And that model is here. And when that gas station message is coming through Kafka, you already studied Kafka. I will just look at the model. Hey, what is Suresh like? Tuck. It will give the answer. But it was created yesterday. The model was created yesterday by analyzing the 20 years of data. Are you understanding? So model is not online. Model is created out of history.
So the model will change on day to day.
Not day to day. How will you change the day to day? So will your pizza preference will become suddenly biryani in one day? No.
But some historical data.
Historical data. That is why the model rebuild will happen every month or every year or every week.
Rebuild.
That's called model deployment and model rebuilding. But one day it will not change. 1 hour it will not change. Even in Google, when your website is down, it will get reflected that your website is down, not next day. Have you ever looked? You make the website down, it will still show you the old website. It is cached. The machine learning models will change. It takes time. So if the machine learning model, which is created out of all this big data, is not changing and it is created weekly or monthly, what is the need of executing MapReduce on that data and doing all these kind of things? I don't bother, even if the network is taking little bit of time. Correct? So, unfortunately, Hadoop is failing. You all studied it, right? But it is failing because of this reason. And who understood this particular reason? Berkeley understood it. Berkeley University, under Mate Saharia, they analyzed this. They understood that, hey, this is a kind of, problem. Iterative algorithms, machine learning algorithms, this is not useful. That's why let me create a new technology. What is that? Spark. So, computation on data. Google published it in 2008. Whole world accepted it. So actually, I think Google published it to make the people think in a different way, and they went ahead and did the Spark kind of computation. But whole world got misled by Hadoop. And now we have installations of the Hadoop without any benefit. The people do not know what to do. They just move the data, one database to another database, another database, another database. What is the business benefit? Zero. So told, hey, this block storage, all this fundamental technology, this history, what all you have told, I am not interested at all. Let's come back. Create a new kind of storage. I will keep the data, the ID associated with the data, and the metadata together, and I will call it as an object, not the Java object or not the object-oriented programming object. Object is a user. No block size. Even if it 1 terabyte, one storage. Why? Oh, look at Hadoop. Yeah, I added 10 nodes in the weekend. But where is my data? It is already in the previous nodes. It is not rebalanced. 10 nodes you added this week only, right? What about the previous week's data? Previous week's data is already there in the 4 nodes. But when you add 10 nodes, automatically, is it sharding? Is it rebalancing? No. And what the admin has to do? Entirely do a rebalancing program. The entire data of the 4 nodes will now be rebalanced to 4 plus 10, 14 nodes. 2 days of work. So, the people started analyzing what is the actual cost of managing this Hadoop. Is it really bringing profit or not? S3 better than HDFS Databricks. Enter. Top 5 reasons for choosing S3 over HDFS. Click. Just come down and look at how the experts have analyzed the cost for managing Hadoop. Cost per terabyte per month, S3 $23, HDFS $206. Availability 99.9, but HDFS 99.9. 19 makes a big difference in the industry. Durability, some 6 or 7 nines, but 4 nines. Transactional rights, yes, but it is comparable. So which is better from this particular chart? You are seeing that a new kind of storage is better. So the people started going for, let us store all these things in S3, and then whenever I want to write my machine learning algorithm, I will use Spark, I will use any technology, I will load the data and I will execute my analytic algorithm. I will create my model, which is my, the juice of my data. And whenever the online transaction is coming, I will refer to this model and I will just give the prediction. And I reduced my cost drastically. I don't have the problem of this. I am getting all my results of my online transactions as usual, as fast as possible. And it is very, very simple to use. So, let us create something called a simple storage service. Take SSS and call it as S3. Who invented that particular one? Amazon. So when you log into Amazon, so I am going to log into Amazon, and if you start clicking on the Amazon and give your ID, and it will ask you the IAM, which is the multi-factor authentication, which has to be configured whenever you are using Amazon. This you might have done if you have already set it up. So Amazon Web Services, I will get a number, and that number I have to type on the phone so that it is not duplicated, and then click on submit. You are in Amazon. So now you have stored into Amazon, you have logged into Amazon. And if you are looking at the services, you will see the magic how Amazon has created. So, if suppose you want to do something related with compute, there is Elastic Cluster, there is Lightsail, there is Elastic Container Services, Elastic Kafka, Lambda, Batch, Elastic Beanstalk, any of these things you can do. If you want to go for storage, there you go, S3, EFS, Elastic File System, which is like Windows, normal file system. S3 Glacier, they told that, okay, if you want to archive the S3 data, I will give you a cheap version of S3, that is called S3 Glacier. Then you have backup, then you have storage gateway. All these are there for storage. Then you have got databases. You got RDS, DynamoDB, which is equivalent of MongoDB, Neptune, that is graph database, Redshift, all these things are available. You can use all these databases. And it allowed me click, and I created it in 5 minutes. My production system is ready. No data center, no security, no infrastructure, no problems at all. When I want to add more users, I will just configure it telling that, okay, grow it, elastic. So that automatically it will grow, it will scale. Only thing you need to pay money for the increased load. That is how Amazon has envisioned it. And it all started with a small story. You know Amazon, whenever you order the things, you get the things in the next day. That was their business. Jeff Bezos started it by selling books in a garage, correct? Then one engineer told that, okay, I am going to create a platform for Amazon. Then Jeff Bezos and the team told that, okay, if you are creating the platform, why can't you make it in a configurable way so that the whole world can use that particular platform to create it? So they created data centers almost all the places in the world. So if you are just moving this particular window and if you are looking at global, and if you are looking at US North, US Ohio, North California, Oregon, Hong Kong, Mumbai, Seoul, Singapore, Sydney, Tokyo, these are all the data centers of Amazon. You can just log in and create your data center, apply that, and then use it. Of course, in healthcare and banking and all, some verifications and security are pending. That is why the entire data is not moved. So in S3, you can just go there, services, and click on S3, which is the storage. And click. After that, you are telling that, okay, I am going to create. So you can see my image, Ravi, passionbytes, all these are the directories that I have created, but don't use the word directory in an S3 world. What is the word that you will use? Bucket. You create a bucket. Can you create a bucket within a bucket? No. A bucket is for data, and a bucket can contain up to 5 terabytes of data as one single store, not blocks. And the moment you create in S3, it will automatically be backed up by Amazon. So if suppose it is failing, it will immediately get you the data. It is in the cost that you pay, automatic backup. And you can keep all the images. You can create a new SP, create a bucket. You can just click on create bucket and then create a particular bucket. It will give you the ID, password, and all those kind of things. And you use that ID and password for that. Right? That's the fundamental. And anybody, just $10 course if you take, you can start using Amazon Cloud and pass the examination, Cloud Partitioner, which is not difficult. If you pass Cloud Partitioner, the next level is Solution Architect Associate. Little difficult, but it's okay. Then you get Solution Architect. And then you can go for the specialty in big data. Specialty in big data is, once you get it, you are proving to the world that you are one among the privileged people. That is the toughest exam in the world as of now. Every certification is available for 2 years. And it is having high demand in the world currently. So spend some time, log into this particular one, create it. There is Cloud Guru that I have taken for my certification exam. So I passed a solution architect last year. So you pass that, you take that particular course, it will show you, and it is $10 to learn. How to create a bucket, how to create a particular application and all. And there is something called Cloud Stack. And what is Cloud Stack? All the scripts for creating the instances, database, S3 bucket, your web server, your application server, everything is scripted. And you click on one button, tuck, 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 tuck. all that script will get executed. The entire platform of web server, database, S3, all connections, all security, everything ready in 5 minutes. So imagine the power where the world is going. Netflix is on AWS completely. Amazon, full Amazon is on cloud. Right? So it allows you to have a decentralized architecture without data centers. The only requirement that you need is moving your data. So the moment that will become democratized, Amazon guarantees that your data will not be used by Amazon at all. But there are some eligibility restrictions by the government and all those things to be cleared. As far as healthcare is concerned, so many services in Amazon currently are HIPAA eligible but not HIPAA compliant. The moment it becomes HIPAA compliant, everyone will go.
But will it happen?
It will. Right? And to show you an example of what I'm doing very, very recently is that I'm going to take a service called Amazon Comprehend. So if you're looking at services, and if you are coming down and searching for machine learning, in the machine learning side you will see some of the services, and Alexa integration is also one of the service you can see on the right hand side. So you can easily buy an Alexa device and start creating your own skills. It is fun, very nice one, right? And Amazon Comprehend, I'm going to click on Amazon Comprehend, and when you click on Comprehend, you will see Amazon Comprehend Medical. And I'm going to click on Amazon Comprehend Medical, launch Amazon Comprehend Medical. And please look at this. I have got a radiology report. So I'm going to show you a radiology report, which is there in my data directory, I think. Data directory. And inside that also, okay. So this is a radiology report. Downloaded from internet. In the world of insurances, whether it is auto insurance or healthcare insurance or any kind of insurance, the people want to look at that particular report and check for whether some surgery, operations, or some x-rays or something happened. Then depending upon that, they will come to the claim. Oh, okay. X-ray. Is there an X-ray in this report? Okay. X-ray is chest, but accident was of chest? Yeah, okay. So chest, yes, everything is matching, approved. Otherwise, reject. In organizations, all these reports are not linked with the claims. They are all separated and they are all stored in a separate system. And this creates big complexity. Why? Because when the auditor or the person who is approving the claims, they need to log into that particular system, goes through thousands of documents, find out what document is attached with that particular claim, because there can be many documents claimed from the claim. And then approve, which is a very big time consuming process. So what we can do, first you write a Spark program to take this and convert into text. What did I use for that? PDF box, if you remember. All that I taught you. So using that PDF box, a PDF report, I converted it into text. And I have got this particular text file. So I'm going to show you the text file, which is there in my, let me just find out. Downloads, ABC demo, Alexa skills, Amazon work. I don't remember where it is. Real estate, ABC demo, Amazon work, let me just check where it is. Okay, so CD, AWS, CD AWS comprehend. So inside Spark code, inside the Spark code, where is it? 1 minute, let me just find it out. Yeah, Spark code, employee and component. So I have created this file called result.txt. I will make it bigger. It is exactly the text of that document, PDF document that you have seen. Now please look at this. I'm going to copy this, Control C, and I am coming to Amazon Comprehend, which I have just opened it, and I am going to paste that in front of you. That text I have pasted, okay? And please look at this. I have just pasted that text which you have seen just now, and I am just going below and I have to minimize it. Please look at the magic that it has done. It has created a beautiful visualization tree of that particular document with all the medical terms which is used, how it is linked. 40 years mother, it was high school teacher, and there was a sleeping trouble. Clonidine was the medication, and this particular report is of radiology, and the lungs clear, the system is all this clear, and these are the medications. It created it, and it has given me a table with 4 columns: entity, type, category, and traits. And the moment I load this into Elasticsearch and create a tag cloud, it will highlight me what is the word that is maximum used in that particular document, so that if a claim is being processed at that time, if I show it on the right hand side, if you want to do this manually, and if you want to create this particular project, at least 20 people, very highly paid machine learning experts, about 1.5 years of work, which is done in 10 minutes. So this is all what I can tell you. So if you can imagine what is going to be the future, it's up to you. If you still work on your drag and drop mechanisms and all, you will be here only. You cannot grow. If you want to change, this is what. Immediately, you should move, and wherever opportunities are there, you should start using it. Next 10 to 15 years is going to be Alexa, devices, cloud. The whole world is going to be changed. The moment all the things that you have studied are going to be applied on the cloud. There is MapReduce, there is Spark, there is technology, there is machine learning, there is model, but everything is on this. And this is a classic example which is shown in front of you. And if you want to see another one, okay, this is a very interesting one. So what I'm going to do is, let me take a picture, right? So I'll post that picture in the group, right? So I'll take your picture. Okay, please smile. Faster, smile. Okay. So I'm posting it into the group. All right. Now what I'm going to do is I'm going to start WhatsApp on my this one. Okay. WhatsApp web, right? WhatsApp web, right? Okay. And I'm going to load that particular picture. Okay. So load how more and what is it? WhatsApp. Okay. And WhatsApp web. Okay. Is loading the WhatsApp, and just now I have taken the photo, and this is the photo that I have taken, right? And I am going to download this, and let me keep it on my desktop. It's in the downloads folder. Okay. Good. I am coming to Amazon and I am going to use Amazon recognition, which is another beautiful machine learning service. And what I'm going to do, facial analysis. Okay. And I'm going to upload the pictures that I have just taken from you. I selected that picture and I chose it. It is analyzing, and that is a beautiful machine learning algorithm that is going on. And it identified that first Bhaskar, I don't know why, 100% appears to be male, age range 32 to 48 years old, smiling 62%, not wearing glasses 99% not wearing glasses, not wearing sunglasses 99.9%. How is that? And now the next person I am going to look, okay. Oh, that is Ravi. Looks like the face, appears to be male 95%, age range 32 to 48, smiling 97%, appears to be happy 97%, not wearing glasses 99.9%. Next, that is Saigo, looks like appears to be male, age range 43 to 61 years old, not smiling, appears to be calm, wearing glasses 83%. Let's look at Lakshmi, whether it got clearly or not. She's a little far, but let's see. Appears to be a female, 54.9%. It is because of the distance, the clarity and all. But remember, it is finding out. Smiling, 53.2. Appears to be happy, 54%. Not wearing glasses, 54%. So as the distance increases. And this particular project, if you want to do, my personal experience, 6 months, 10-member team in Pune tried for doing this particular thing and they failed. And I get it for 5 minutes. And all these, a Java program is available. Just to call the API, give the keys, get the value.
Why did they not apply this on the Aadhaar card?
On the?
Aadhaar card in India.
Yeah, they can. That is what I'm saying. Applications are tremendous. So what I am currently doing is, you might have seen that Alexa skills and all those things is, I have a Raspberry Pi and I am attaching a camera to Raspberry Pi and it is taking a picture. It is calling this recognition from the Raspberry Pi and it is finding out the image. So Bhaskar's image I already stored. So there is another module. It will identify that, oh, this is Bhaskar. Understand? And I will look at a database, Bhaskar, and I will look whether yesterday he had sent me a reminder. So Bhaskar has sent me a reminder yesterday telling that today I will be coming to bank for checking my credit card problem. So Bhaskar came, it will show in the screen, oh, you came for credit card problem, please come, automatic. So I am thinking of creating a new kind of customer service. So that automatically it identifies, automatically it shows what is the problem and it will lead you to that particular person and everything is ready for you. We can package it and sell it. That's my idea. Okay, so studying is one thing. Start applying. I'm telling you what is there. 4 or 5 years back, I told the people Hadoop is going to be a hit. They didn't listen, and now you are attending Hadoop. But now I am telling you that this is going to be the future. Start applying. Spend a little bit of time. This is not difficult. Look, upload button is there. I am uploading it and I am using it. All you need is how to call a Java API. The complete example code, everything is given. Everything, all the things are given. Right? So tomorrow we'll see how to install Minio and I will show you a magic with Presto again. Make sure Presto is installed. Okay?
So what is the Udemy course, Ravi, for this one?
1 minute. I get it close. Say intro to